We know that if we increase our sample size that we can decrease our standard error, which decreases our margin of error and makes us having a narrower confidence interval. So the question may be, if we have a specific size of interval we want, a specific margin of error, how do we find the sample size to accomplish that? If we set our margin of error equal to the stuff after the plus or minus in our formula, we get margin of error equal to z times the square root of p hat times 1 minus p hat over n. And we can just use some algebra to solve this for n. So if we move everything around and solve for n, we end up with this equation. So if we're asked how big a sample we need, we can plug in all of our information here and solve for n. There's two cases of this which are listed on the next page, which is what do we do with the p hat value? Possibly if I'm trying to figure out how big a sample I want to take, I haven't taken a sample yet. And in that case, I would not have a p hat to plug in there because that is a sample value from a sample we've taken. And if we do not have a guess for what p hat it would be, or like a preliminary estimate, what we would do is replace p hat with 0.5. And that is just because that makes this sample size as big as possible, so we make sure we take a big enough sample. If, however, we do have a guess for p hat or an initial estimate to give us a p hat, we can use that value instead. So on the next page, we have a couple examples. I'm going to go through both of these. So those are the two cases I just mentioned. In 6.1.7, we had that 44% figure from the initial poll of if people thought it was too hard to adopt. And we're wondering how large a sample size would we need to make sure we get our confidence interval to within plus or minus 2% using 99% confidence. So in this case, what we have for our information is that we want our margin of error to be 2% or 0.02. And we know that if we're doing a 99% confidence interval that we have 2.575. And then further, we have this estimate already. So this is our p hat value that we can use. So this is this preliminary small sample. Use that value of p hat, bullet point 1 up here. So plugging everything in, we'll get n equal to our z divided by our margin of error. That quantity gets squared times p hat times 1 minus p hat. This produces 4,084.465. Now, we're talking about a sample size, and that needs to be a whole number. So usually when we round, if we're below 0.5, we round down. If we're above 0.5, we round up. The case for looking at sample size is we're always going to round up. Because really what this is telling me is that I need a little bit more than 4,084 people. So we always want to take whatever we get for our value here and round it up to the next whole number. So our answer in this case would be 4,085. The other example here then says a company produces plastic bottles, millions a day. They can't check every bottle for defects, so they check a sample of bottles. And no preliminary sample has been taken, which what that tells me is that I don't have an idea of what p hat would be. So we're asked how large a sample of bottles would we need to get a 95% interval that estimates the proportion within 4%. So our margin of error that we're interested in now is 0.04. Because we're doing a 95% confidence interval, our z would be 1.96, and we have no p hat, no value there. So what that tells us is that we use a value of 0.5. That's just going to produce the largest possible sample size for that case and make sure we're taking a sample that's big enough. So we have our z over our margin of error squared. Since we don't have a p hat, we do 0.5 in place of that value. This will produce 600.25, and as I just mentioned, we always round up to the next whole number, so our answer would be that we need a sample of 601 bottles.